Truth tables. A truth table is a device that we use to determine when a compound statement is true and when it's false. With truth tables, we assign all possible truth values to each statement and then use those cases to see how that would affect the conditional or the compound statement. At this point, we don't care what the statement is, we don't care whether it's true or not, we're just looking at how to evaluate all the possibilities. Negation. We know that the possible truth values for any statement P are true and false. So we're going to start off by listing, we're going to show a table and we're going to list all the possible cases. P could be true or false. To evaluate statements, the negation of P is going to have the opposite value as P. What we'll do is create another column over here and we'll base the possible truth values on the column where we've listed all the possibilities. So P could be true or false. If P is true, then that means that not P would have to be false. Likewise, if P is true, then not P would be true. We're looking at all the possible values of P and seeing what that would cause not P to be as far as true or false. If it helps, you can make up a statement to help you evaluate the case. Let P be I like pretzels. If the statement I like pretzels is true, then I don't like pretzels must be false. That makes sense. Likewise, if the statement I like pretzels is false, then I don't like pretzels must be true. Alright, conjunction. The AND statements. When we have a compound statement such as P and Q, we're going to add a column for the possible truth values of the new statement. Note that each new statement or each new letter is going to double the number of possible outcomes. In other words, one statement has 2 cases, 2 statements has 4, 3 has 8, 4 would have 16, and so on. A conjunction is only true if both statements are true. Alright, so let's look at a table. We've got a table with cases. When I'm working on these cases, I usually take the first statement and I make half the cases true and half the cases false. Then I take the next statement and I look at my true statements and again make half of them true and half of them false. Then I look at my false statements and do the same. There are 4 possible cases here. It could be that P is true and Q is true. It could be that P is true and Q is false. It could be that P is false and Q is true. It could be that P is false and Q is false. Those are the 4 possibilities. So, looking at the conjunction, we have true, true, false, false, and true, false, true, false. And a conjunction is true only if both statements are true. So in the first case, P is true, Q is true, so P and Q is true. Notice that in all the other cases, at least one of them is false, so this AND statement is false all the way down. Again, if it helps, make up example statements. For example, let P be I am eating macaroni for lunch, and Q be I am eating cheese for lunch. The only way I can be eating macaroni and cheese for lunch is if both of the statements are true. If P is true and Q is false, I'm not eating macaroni and cheese, I'm just eating macaroni. Disjunction. Disjunction is true if either statement is true. In other words, the only time it's false is if both statements are false. So looking at our cases here, we've got P or Q. Is at least one of them true? Yes. Case 2. Is at least one of them true? Well, yeah, P is true. So the P or Q is true. Look at case 3. Is at least one of them true? Yeah. And finally, case 4. Is at least one of them true? No, it's not. So the only case of a disjunction being false is when both statements are false. Now, when we get to the uglier, more compound statements, it can be helpful to create some extra columns for us. For example, construct a truth table for P and not Q. So what I'm going to do is add a column for the not Q, because I'm comparing a P to a not Q. So eventually I'm going to be looking at this P column and this not Q column. So let's see, if Q is true, then not true is false. If Q is false, then not Q is true. And again, Q being true means not Q is false. Q being false means not Q is true. Now, when I go to look at this column where I'm doing the and, I think I may have said or just a second ago. When I'm looking at P and not Q, we're going to ignore the original Q column. We don't care about that anymore because this last one is comparing P's and not Q's. And again, conjunction is when both are true. So it's true if both true. So let's look. We've got a true and a false. That's not true. That's false. We've got a true and a true. Then our statement is true. We've got a false and a false. It's false. We've got a false and a true. That's false. Again, it's only true if both of the two columns we're comparing are true.